Experimentation 2020 by Causation. Being a scientist doesn't just always mean having a lab coat or glasses and cool chemistry bottles. Looking like those crazy mad scientists you see on TV doesn't make you an actual scientist. Thinking innovatively does. To think innovatively means to be open-minded to different ideas or theories, and that's what being a scientist is all about. A scientist has to be able to think innovatively to discover new things and test the world we live in. Experiment 1. Dr. Sean Devadison. Kushan's question. How does the substance aluminium affect the speed at which water evaporates? Purpose and hypothesis. Purpose. To change the internal chamber of a solar bottle from plastic to aluminium to see if this speeds up the evaporation process. We will be testing to see if we can speed up the evaporation process by changing the internal chamber from a plastic bottle to a type of metal called aluminium. We will be comparing how much water evaporates from the plastic cup compared to the aluminium can, thus informing us if aluminium can in fact speed up the evaporation process. By measuring how much water has evaporated, we will also be able to estimate how much clean water we can produce over one day using this method. Hypothesis. We hypothesize that if we use an aluminium container instead of a plastic container to hold the water, then the evaporation process will speed up and we will be able to produce a larger amount of evaporation in the same time frame. Variables. Independent variable. The independent variable of the two different materials, plastic and aluminium, we will be using to hold the water in. The dependent variable is the amount of water left in the aluminium can and the plastic cup. This will inform us how much water has evaporated. Controlled variables. The plastic container that will go on top of the aluminium can and the plastic cup. The surface which we will be placing our aluminium can and the plastic cup. The room temperature. The level of sunlight exposure. The amount of water in the containers to begin with. And the length of time both containers will be in the sun. Click one of the two links to see a presentation that will inform you how to do Experiment 1. The link on the left will take you to a website showing the presentation. The link on the right will take you to a YouTube link showing the same presentation. Observations. At 9 a.m., the experiment was set up. No condensation was noted on the enclosures, and both containers were cold to touch. At 11 a.m., some condensation has started to build up on the enclosures. More condensation is noted on the aluminium cans enclosures than the plastic cups enclosure. The aluminium can was quite warm to touch. The plastic cup was a little warm, but not as warm as the aluminium can. Observations. At 1 p.m., lots of condensation was noted. The AC enclosure had so much condensation that drips of water could be seen dripping down the inside of the enclosure. Additionally, a rim of water had built up at the bottom of the enclosure, as you can see in the photo on the right. Both the containers were warm to touch. Experiment 2 by Eugene Wang. Eugene's question: how does aluminium affect the speed of evaporation? Purpose and hypothesis. Purpose. The material I will be testing is: does the aluminium can impact on how water evaporates, like speeding up the process with the help of the sun's rays? Hypothesis. I hypothesize that if we change the independent variables, then I hypothesize that the evaporation process will speed up because of the aluminium. Variables. Independent variable. The two different materials, plastic and aluminium, we will be using to hold the water in. Dependent variable. The thing I will observe and measure is how much water it can produce and how the change in temperature can affect the production of water. Controlled variables. The greenhouse effect, the temperature, the surface that we will be placing the containers on, the same amount of water, the same amount of time. Eugene's evaporation experiment. Step 1. Setting up the materials. My experiment started with gathering the materials that I needed for this experiment. Any pencil or pen that you can write with, any amount of water, but it has to be the same, preferably 400 milliliters, a sunny place around your house, a notebook, a plastic container, measuring tools, a stopwatch or something that can tell the time, something that's sharp that can cut through aluminium, a rubber, just in case. Step 2. Cutting the aluminium lid. Using something sharp, in this case my pair of extra sharp scissors, if doing this experiment by an aluminium tin or can, you have to do this step. But for me, I'm using a cup. And then weigh the aluminium cup or can and the plastic cup to make sure to record the weights in the notebook. As my scissors are made to cut meat, I had to make sure I had parent supervision to cut the aluminium bottle. Step 3. Pouring the water. I poured half of the water into each of the containers, the aluminium can and the plastic cup. Step 4. Sunny place. While I was doing this step, I make sure you place the aluminium cup and the plastic cup somewhere where you know not one or thing can knock it over, or make sure you place the experiment where it's sunny. Step 5. Setting a timer. After I have done all these steps, I made sure to set a stopwatch or a timer for every 5 hours after I placed the other container covering over the 2 cups. Step 6. Recording results. After I both the bottles on a scale at the time every hour for 5 hours, I have to record the results on my notebook. I then subtracted both how much the cups, other known as bottles, at the start weighted when I saw how much water evaporated from the 2 bottles, by whoever's evaporated most water in the same conditions. Step 7. Packing up. Packing away my experiment, but there's some small safety concerns, like you might walk with sharp scissors sticking out. That's the end of my experiment. Results from experiment 1. The chart on the left informs us the quantity of water evaporated in millimeters after every 2-hour time period for 8 hours. The x-axis shows the different time intervals, and the y-axis shows us the amount of water evaporated in milliliters. As you can see, the AC heated up much faster than the PC, and so more had evaporated earlier in the day. After the PC also heated up, the evaporation rate was similar for both. The table on the right informs us of the average amount of water evaporated over 5 intervals in an 8-hour time period. The x-axis tells us which container the water was in, and the y-axis tells us the quantity of water evaporated on average across the 8-hour period in millimeters. As you can see, the AC has more than twice the average evaporated rate over the day. Results from experiment 2. The chart on the left informs us the quantity of water evaporated in milliliters after every 1-hour time period for 4 hours. The x-axis shows the different time intervals, and the y-axis shows us the amount of water left. As you can see, the AC heated faster than the PC, and so more had evaporated earlier in the day. After the PC also heated up, the evaporation rate was similar for both. The table on the right informs us the average amount of water evaporated over 5 intervals in a 4-hour time period. The x-axis shows us the times when the water evaporated, and the y-axis shows us the amount of water left. Reflection. The original hypothesis was that aluminium could speed up the process of evaporation because it is a metal which conducts/absorbs heat. Our observations have proven this hypothesis to be true. The hypothesis was based on an ice experiment that we had done, testing if different surfaces could make the ice cube melt faster. We learnt that the metal was a conductor of heat, and so when in a room around 20 degrees Celsius, the metal quickly absorbed the heat, thus making the ice cube melt faster. We have now proven again that metal is a conductor of all temperatures, and so it can become the temperature in the environment around it faster than most surfaces. To research further into this topic, we could experiment with different sized openings in the aluminium can to create the greenhouse effect. Further research. To research further into this topic, we could reduce the size of the opening on the aluminium can to see if this increases the greenhouse effect inside the can, and therefore speeding up the process of evaporation even more. This experiment was done on a cool, cloudy day, to be exact 15 degrees Celsius. If we were to conduct this experiment again, we would like to do it on a hot sunny day to see what the impact this would have.